So the makers of math continue to just torture you with the idea of anything you can do one way, you can do it backwards. So here we go. Everything that you know and hopefully have become a little more solid on, now we'll do it backward and confuse you. Because this will sort of crowd out some of the memories that you have. But if you get this straightened out, then in the long run it'll help you if you know everything inside out. We're doing integrals today, so we've been doing derivatives. You've got a bunch of new things that if they're not on your card yet, you want to get those on there soon. This would be another 3 superstar rules that you want to do on your card. So integral or antiderivative of e to stop. Make sure the derivative of the stop is present, and if it isn't, fix it. But the integral of e to stop, as long as the derivative of the stop is present, will be the same e to the stop plus a c. That'll be a popular integral. If we go to do the integral of any other number to a power, again, make sure the derivative of the power is present. If it isn't, fix it. But as long as the derivative of the power is present, the answer will be that same thing to that same power, but on top of a logarithm of the number that's the base. So if it's 3 to the power, you'll get an ln3 on the bottom. Third thing we'll have, if it's a fraction variety, possibly it's going to be a setup where there's something on the bottom and its derivative on the top. If you can maneuver the problem so that the thing on the bottom has exactly its derivative on the top, that'll be an ln answer. It'll be ln, and they're going to make you put absolute values around the thing on the bottom because ln's are picky. You can't do ln's of negatives, just like you can't square root negatives. That's just not a thing we can do. But most of the problems today will fit one of those 3 types, and then on occasion it won't fit a type, and we'll talk about that when we find it. But we've had problems before that didn't fit a type. It'll be the same trick we used to save ourselves with. Question about the 3 concepts, and you want to get those on your card. So this is clearly type 1 because it has an e in it. So you want to focus on the power and make sure the derivative of the power is present. Is the derivative of the power present? No. So make it be present by creating a 3. You can't just pencil in a 3 without paying for it. How would we pay for that? A 1/3 would pay for that. Now we're good. The answer will be the 1/3 that was our payment, and then e to that same power plus a c. Question there? Next one, clearly same type because it's a get an e. So the question to always ask yourself, is the derivative of the power present? Yes. So we're good. Just answer will be. If I threw a 3 here, I would need to also throw a 3 there as the creator of the problem. You can't do that. You can't change the arguments of the trick things. So as the creator or the author of the problem, I would need to make sure those arguments match. But if I did do that, now the derivative isn't quite present. Now what would you require? The 3 paid for with the 1/3, and now we do that. Question on the e's? This is clearly choice 2 because they're still powers, but it's not e's to powers, it's other numbers to powers. So you check the power. Is the derivative of the power present? Yes, so we're good. Answer would be?
The
logarithm of 8. If that had a 7, we wouldn't be okay. Now the problem needs and payment of, so now we get something more like that. Next one, is the derivative of the power present? No, not quite. What do we need? A negative. And we pay for that with another negative. So this answer would be negative. logarithm? If I, as the author of the question, decide to introduce an 8 there, I would also have to introduce an 8 there. If I don't consistently introduce the same argument, you're just stuck. You can't fix that. But if I do that, you can fix that from here. Now, the problem also needs an 8 to answer payment. 1/8. So now we're looking at something like that. Question about those. And then clearly we're in a different type here. Okay? We're no longer e's to powers, numbers to powers. We're in a fraction format. Not all fraction formats will obey this rule. Okay, but check the bottom. Think about if is the derivative of the bottom located, or is it something somewhat close to that out on the top? What's the derivative of the bottom? 2 cosine theta. We have this time the opposite problem than usual. We have more than what we wanted. We only want 2, and we've got 4. So there's 2 ways you could fix this. Okay, one thing you could do is to think to yourself, okay, 4 is not what I want. I want to have 2. 4 is 2 times 2. This 1, 2, I want to be there. This other 2, I don't. So for the first time of many times this year, I'll go like this. We don't want that bonus 2. 2 times 2 is 4, so stick a 2 out there. Now we're good. If you don't like that, alternative thought process that'll land us in the same spot. We have a 4. 4 is not the right number. So 4, then insert the number we do want. Pay for it. Half of 4. Still 2. No matter, you've got to get on a road to do something with that. And at some point, you're going to need in your mind to do this. Like flick that number out of your way. Depends on how you want to manage that. Okay, but this answer will be 2 ln bars 1 plus 2 sine theta plus c, and on life goes. You can only flick numbers. Numbers are movable. Get them out of your way. This. It's a fraction, so it's possibly choice 3, but not every fraction is going to be choice 3. Check the bottom. What's the derivative of the bottom? 2x, so we'll make it be so. That needs a 2. Payment, half. So answer. Logarithm. Generally, we do the bars. And they're going to change this one, just one little tiny tidbit if this opportunity presents itself. Either of you have a thought on why this one is slightly changeable?
You don't need the bars.
We don't need the bars. Why? Squared, as long as it's also adding, yeah. If this was x squared minus 7, the subtract would make the bars necessary. But x squared is for sure positive. Adding 7 is for sure positive. The point of the bars is making sure we have positive, but we don't like looking at bars. No one likes looking at bars. So if you get a chance for some reason to soften the bars into parentheses, we'll take that trade if we can do it. This one is a complete failure. Okay, so if we do the derivative of the bottom, that would be 1. That's not even remotely what we have on the top. And we can't take that top and flick it out of the way, because you can't flick algebra things out of the way. You just have to deal with them. If that's like a 2 or something, we can get rid of 2s. Multiplying can go now, later, whenever. But no, that can't be done. And this is even worse. Derivative of this is still a 1. That's not even remotely what we have on the top. So we're going to need a different approach. Any recollection of days gone by when we've done integrals and we're looking at it and we're like, this is not a problem I can do right now. Do you have any memory of how we used to try to deal with that? We'll come back to this. We'll let that stew for a minute. We'll come back to that in a moment. This one we can do, because using trig tricks, tan has been our friend before. Tan is always sine over cosine. Now that it's a fraction, it is maybe like that third type, is the derivative of the bottom located on the top, more or less.
Almost.
Yeah. Is it perfect or is it a little bit off?
It's a little bit
What's a little bit off?
negative.
Negative. So if we had a negative, we could pay for it with another negative. This is going to be the logarithm, bars, bottom. Well, I should get a negative in there. Plus a c. Alternative plan would be to go positive. What did we learn on logarithm trick day? What could negative logarithms allow us to do? Essentially flip.
Okay.
Flipping cosine? C. I'm not sure which of these two the book prefers, but this is card worthy. Hand problems, you could either go negatives and deal with cosines, because you might prefer a cosine. Or you could go positive, because you might prefer positive, but then you have secant. Toss up as to which of those anybody would consider simpler. I'd consider cosine simpler, but I'd consider positive simpler. So I don't know what to tell you on that one. If we go to do cotan, cotan could instead be written cosine over sine. Is the derivative of the bottom more or less on the top? Yeah, perfectly or tweak? Perfectly. So this would be ln
Sine
with bars. Another possible way you could do this would be negative ln bars and cosecant. But I don't know why anyone would do that other than just a need to show off or be thorough or something like that. But if the book does that, those are the same. But obviously, positive is better than negative and sine's better than cosecant, so I'm not sure why that one would really be useful to them. If I sneak a number in there, this is more like the first pattern. The answer is going to have something to do with ln bars plus c's. Would you rather go negative cosine or positive secant? Your call. Positive secant. Bring the 2x with it. What's one minor adjustment we'd have to make to this one? A half. The derivative of the 2x requires a 2, which requires payment of a half. So that would be the grand total answer on that one. Maybe when you go to do your card, maybe you want to do tan u and a du to just emphasize again, whatever tan has, its derivative needs to be present. And then pick which ever of these you prefer better. Maybe the same thing here when you put this on your card. Maybe throw some u's on there. The u is generally serving as a reminder, like the u represents an algebra piece. The du represents the derivative of the algebra piece. If you write things on your card with a u, that might spark your memory to check the derivative a little bit better than if you don't. That's about that. Okay. So any recollection come to mind while it worked on while your brain was running in the background there for a minute? Things we used to do whenever it's just not quite fitting the pattern? We're going to pick a u. We're going to do integration by substitution. We're going to pick something that's kind of ugly, but not too extremely bad, and just make that be called u. In this case, something that's not too scary, but you'd rather not see it, would be ln x. Then we figured out a derivative of that u. Derivative of ln And I should try to remember to always put a dx in the problem. Sometimes I forget that. Those are there.
Do a U over U.
Yeah, so on the bottom, we throw an x. On the top, a 1. Dx, if you like. Then this problem takes on a new name. ln x is now being called u. That thing right there is now being called du. And then we'll just do the antiderivative. The u becomes, when we do the antiderivative,
Half U squared.
it'll be half u squared. And then when we go to do the final answer, we re-replace the u with ln of x, which you could either write like this, or trig style, you can nestle that square in there. Pick one, doesn't matter which one. Something like that.
Can you do where the power multiplies to the front and
No. No, if we had this, that power can move to the front because it's part of the ln. This power is surrounding the ln in a different one. Something there. This one we would take a different approach. Okay, I'm going to leave the x alone. I'm going to leave the dx alone. Log base 2 of x, we're getting into it was more of a calculator usage issue. If I asked you to do log base 7 of 12 on your calculator, do you remember how you could punch that in?
log 12 divided by log 7.
Would you go log 12 divided by log 7 with either the log button or the ln button? So here, log base 2 of x, we can make ln x divide ln 2. The ln of 2 is just a number. ln of 2, it's a weird number, but it's just a number. This ln of 2 on the bottom, you could basically just go, clink. And the problem we just did is the problem that we now have just with this extra thing under my hand. So we're going to get that same answer, but instead of 1 over 2, it would be 1 over 2 ln 2. But the ln of x is getting squared plus c. Question about that little bit of gymnastics? We're usually here 2 days. We don't have to be here 2 days, but we're usually here 2 days. So homework for day 1 of this, we're up to 377. Just doing a whole scattering group of odds. There's not really a pattern to it. It's not all the odds, but it's not skipping in any sort of like normal way. It's just all over the place. Then if we want to do the evens for a day to get more practice, we would just do the next ones up. And then I already gave you your sheet. The sheet would be due whenever we decide the sheet would be due. That could be Wednesday if you only want to do 1 day of book homework. It could be Thursday if you want to do 2 days of book homework. You'll probably want a second sheet, and we'd be looking at a quiz like late this week, early next week. Something like that. That's a wrap for record.